is giving you a copy of this. I don't know if I have posted this already. I forgot. But anyway, if ever hindi pa, ibibigay ko ito later. Group 2, group 2 sa laboratory. Anong activity na kayo with Ma'am Perlado?
7 po, ma'am.
7. You started already or ano pa kayo later?
Mag-discuss
Magpasa na po, ma'am. Magpasa na po kami later.
So you are done with activity number 6?
7. Yes
Yes
po, ma'am.
po, ma'am. Yung sa molarity po.
Okay, sige. So I think all groups are already done. Let me just give you more examples because our lesson for this morning is actually about concentration of solutions, including molarity and also dilutions. And then if I still have time, I'll be discussing also gravimetric analysis, acid-base titrations, and redox titrations. Okay? So pantay lang pala tayo with the group 1. Yung may mga corrections sa quiz, pasend na lang sa Schoology ha, kasi open ko yan later one by one to recheck your submissions. Okay? So again, let's talk about concentration of solution. Pag sinabing concentration class, it is referring to the amount of solute that is dissolved in our specific amount of solvent. Again, pag concentration, amount of solute dissolved in a specific or given amount of solvent or in a solution in totality. So one expression of concentration that we have is molarity. So hindi lang yan siya molarity ha, most of the time you will see in percentage. Like for example, when you say 100% concentrated, it means you have there 100 grams of solute being dissolved in 100 ml of solution. So yun yung ibig sabihin ng 100%. Meron din tayong normality, but we will have the normality in your Chem102 na lang. We also have formality and molality. So this time, we will just concentrate with molarity, which is represented by the number of moles of solute. So again, we are referring to the number of moles of solute ha, kasi di ba pag sinabing concentration, amount ng solute, tapos dissolved in a specific amount of solution. So kaya molarity is moles of solute divided by liters of solution. So the symbol for molarity is capital letter M. However, for moles, we can actually use the symbol N, and V is for volume. But take note that our volume should always be in liters if we use moles for the solute. So keep in mind, again, that volume is in liters. Okay, liters of solution yan siya, not liters of solvent. So pag solution, it's solute plus solvent. So in totality na siya, volume of solution. And molarity actually depends on temperature. Bakit? Kasi meron tayong solute class na madedissolve siya if the solution is hot. Diba? Most of the time, pag nag-timpla taog anything in our home, most likely ginaboil nato ang water. Example, milk. So milk can be your solute and then we are going to dissolve it in a boiling water kasi mahirapan tayo mag-dissolve kapag cold water ang gagamitin natin. Yun yung ibig sabihin ng molarity is dependent sa temperature. So nakadepende kung anong temperature madidissolve si solute, then we will compute for the molarity. One example of a solute or a chemical species na madidissolve lang siya kapag cold ang solution is the calcium hydroxide. The rest kasi most of the time we know, 'di ba, na dapat mainit yung tubig na gagamitin natin in dissolving to facilitate solubility. Pero again, calcium hydroxide is more soluble to water if it is cold. If you have questions, you can unmute yourselves ha, or just send your questions sa chat. So we have here an example, a 1.46 molar glucose solution. Glucose is C6H12O6. That is our physiological sugar or the blood sugar in layman's term. Is written as 1.46 molar. So this is how we write the concentration followed by the chemical formula. And what does it mean? When you say 1.46 molar, it means that it contains 1.46 moles of our solute, which is the glucose, and then this one is being dissolved in 1 liter of solution. So that's what it means by 1.46 molar. But of course, hindi naman lahat ng volume ng ating solution sa laboratory ay 1 liter talaga. So minsan 500 ml depende sa ginagawa natin na solution. So pwede tayong mag ratio and proportion here. So kung 500 ml lang yung ating solution, we can actually convert that into liter. That's 0.5. So ang mangyayari kung gusto natin na 1.46 molar pa rin yung kanyang concentration, it means bababaan natin yung kanyang number of moles. So magiging 0.73, kalahati na lang din ang number of moles kapag kalahati lang yung solution natin. So yun yung ginagawa natin sa laboratory. So again, it will be dependent on the amount of solution also. Now take note that molarity or concentration is actually an intensive property. Sa prelim, nag-discuss tayo ng difference between extensive and intensive. Extensive when it is dependent to the amount of matter being considered, just like volume. So if you add more matter sa imuhang gina-measure, then definitely tataas din ang volume ng substance. That's extensive. But concentration is intensive, which means it is not dependent on how much of the solution is present or how much matter is being considered. So just like when you have 1 glass of juice and it's 100% concentrated, tapos you have 1/2 glass of juice pero it's still 100% concentrated. So hindi nagbabago class yung kanyang concentration. Pwedeng magbago ang kanyang volume pero hindi nagbabago yung concentration natin unless na lang kung dadagdagan talaga natin siya ng solute or solvent. Pero kung hinati lang natin siya, the 1 glass of water is being divided into 2, meron tayong 1/2 and 1/2. Hindi tayo nag-add either solute or solvent, then the concentration remains the same. So, intensive property siya. So, it is important to keep in mind that molarity refers only sa amount ng solute originally dissolved in water. Now, if you add something, that's another story. So we have the process of dilution. And if kapag may mangyari sa ating solute when dissolved in water, just like when it undergoes dissociation or ionization, di ba when you say ionization, it's the separation of the component of our compound to ions. So just like potassium chloride, pag nilagay mo siya sa tubig, it will become potassium and chloride ion. So, hindi na yan siya kasali in the computation of molarity. Ang pag-compute lang ng molarity or ng concentration is yung original talaga na substance, ang amount nun na dinisolve natin sa solvent natin. So, that's how you compute the concentration. So, in the laboratory, since we cannot do this due to our situation, this is how we prepare a solution if alam natin yung molarity. So for example, you are asked to prepare 1 molar of sodium chloride solution. So yun kasi yung available sa bahay ng sodium chloride. Wait lang ha. I need my pen so that I can write on the screen. Okay. So anong ginagawa sa laboratory? Example, nag-request ang teacher ninyo na gumawa kayo ng 1 molar na NaCl solution. So ang ginagawa, class, we just have to compute ilang grams ang needed nito para makagawa tayo ng 1 molar or 1 m. Pag makompute mo na ito, kung how many grams, example, 1 litro ang gagawin natin. Pag na-compute na ang number of grams, syempre, mag-weigh tayo, example ng 1 gram of the NaCl. Tapos, ilagay natin siya in a volumetric flask. Ito yung mukha ng volumetric flask natin. It's a long neck flask na isa lang ang guhit for graduation. So pag sinabing 1 liter, ito 1 liter lang talaga ang mini-measure niya. And then after, we will be adding the solvent. Most of the time, it will be water. So syempre through a funnel because ang opening ng flask na ito is medyo narrow. And then after that, we will be shaking or swirling the solution inside just to dissolve the solid kasi sodium chloride is solid. After swirling, we will add more water until mapuno siya into the graduation mark. So that will now signify na 1 liter of solution na ang laman ng flask na ito and na-dissolve na yung solute natin. So that's how, class, we prepare a solution na meron tayong target na concentration. So again, that is our process. Any questions so far? Hindi siya ma-picture out kung hindi tayo mag-laboratory. So I hope next time we can really do this in the lab. We will still have this in your Chem102. I just don't know if who will be your teacher, but this is still included in the analytical chemistry next sem. By January to, kailan matatapos yun? May. Okay, so we have here sample problem involving our molarity. How many grams of potassium dichromate are required to prepare a 250 ml solution whose concentration is 2.16 m? So ano daw ang sabi ng problem? If intindihin natin, ang gusto niyang malaman is yung amount ng potassium dichromate that is needed to prepare 250 ml only of the solution and that the concentration should be 2.16 molar. Okay, yun yung ating question. Gusto nating gumawa ng solution. Ito lang yung volume niya. Tapos dapat ito yung kanyang concentration. So meron tayong process, 'di ba, na sinusunod sa molarity. If the weight in grams of the solute is given in the problem, we will compute for the moles. After computing for the moles, we will be computing for the molarity. But this problem is the reverse, meaning the molarity is already given. So what's next? We will still compute for the moles and then lastly na yung weight in grams. So ganito lang talaga, class. Wala na tayong ibang process in the computation for molarity. It's between the two. Depende sa anong hinahanap and anong binigay sa problem. If ang hinahanap is molarity, you start here. Computing for the moles and then the molarity. But if ang hinahanap is weight in grams of our solute, then you start with the molarity which is given and then you look for the moles. Again, before you can compute for the weight in grams. So since based on the given, we are looking for the weight in grams, the molarity is given 2.16 m. And then the volume is also given 250 ml, then we will follow this process. So we will start with molarity. So molarity, remember, is equal to moles of our solute divided by liters of our solution. Pero ang hahanapin natin is the moles. So we can derive this formula. Pwede nating i-derive ang formula na ito, which means magiging moles is equal to molarity times liter na siya. So ganun pag-derive, ibaba mo itong moles. Now we can substitute the given to compute the number of moles. So we have molarity here is 2.16. We can use the unit na moles per liter so that it will be easier for us to cancel the unit kasi kung capital letter M yung gagamitin natin, hindi natin makikita kung paano na-cancel yung unit. Now, multiply natin sa liters, but the given is in ml, so do not forget to convert. So, sa isang liter, meron tayong 1,000 ml. You cancel this, make sure na makancel mo siya, so dapat sa taas and sa baba. Hindi mo pwede ilagay itong 1,000 ml sa taas kasi hindi mo na siya makakancel. So, this becomes now 0.25 liters. So, ito yung i-multiply mo sa molarity. Now, as you can see, we can cancel the liters kasi sa 2.6 moles per liter, nasa baba si liters, ito nasa taas siya. So, makakancel natin siya again. So, we have 2.16 times 0.25 is 0.54 moles. So we have computed now for the number of moles. The next step will be the computation of the weight in grams. So yung original natin na formula is mole is equal to weight in grams divided by the molecular weight. Now, since ang hinahanap natin is weight in grams, therefore, we will also derive this formula. Ganon pa rin, baba mo si weight in grams equals mole times molecular weight. Now, na-compute natin si moles just a while ago, that is 0.54 moles. And ang hahanapin na lang natin is the molecular weight. Molecular weight ni sino? Siyempre, nung solute natin. And that is, in this problem, potassium dichromate. So, the chemical formula is already given in the problem. So, all we need to do is to compute for the molecular weight by listing down all the elements, potassium, chromium, and oxygen, and then identifying the number of atoms. So we have 2 based on their subscript, and then chromium is 2 also, oxygen is 7, and i-multiply natin sila each with their atomic weights. So para uniform na lang tayo, though in the books they don't really round off the atomic weights to the nearest whole number, but sa class natin, just to have everyone's answer na uniform, then mag-round off tayo to the nearest whole number. Can you look at your periodic table? What is the atomic weight of potassium? I guess it's 39 if I'm not
39.
Okay, very good. It's 39. How about chromium? Chromium is atomic weight. Kindly round off. Sa
60.
60?
Yes po,
52,
ma'am.
ma'am.
Na-round off na po. Sorry.
Ano sa man, Jod?
52, ma'am.
52?
52.
52. Okay. Sige, 52. Rounded off na ito ha to the nearest whole number. And syempre, oxygen is 16. So let us compute. 39 times 2 is 78. And then 52 times 2 is, syempre, 104. Okay, trust issues. Okay, and then 7 times 16 is 112. And then we will be adding everything. We'll get the sum. So 78 plus 104 plus 112 is 294. Unit for this, grams per mole. Okay, so now we have the computed molecular weight. We can substitute this now para makaproceed tayo for the computation. 294 grams per mole. We can cancel the mole now. We will be left with grams. So that will be the unit for the final answer. So 294 times 0.54 is 158.76 grams. So this is now the final answer. In the quizzes or in the exam, you just follow the instruction. Read the instructions carefully and follow them. Kasi minsan, yung instruction will be 2 decimal places for the final answer or whole number, depende siya. In the meantime, let's not just have the whole number. Though sa book nito, 159 grams. Mas specific tayo, that's 158.76 grams. So that is the answer now. So meaning kung i-request ng teacher ninyo na mag-prepare kayo ng 250 ml ng 2.16 molar potassium dichromate solution, ang gagawin nyo, mag-weigh kayo ng 158.76 grams ng potassium dichromate na powder, and then lagay nyo siya sa volumetric flask na 250 ml, and then lagyan niyo siya ng konting water, swirl it until ma-dissolve, and then add kayo ng more water hanggang sa graduation to make the volume 250 ml, and then automatic class, yung kanyang concentration yan is 2.16 molar. That's how we do it in the laboratory. So do you have questions for this problem or clarification? Wala. So, okay na ta, Ani? Can I erase now the writings on the screen? I hope nasundan yon. Kay murag, sag-asa na lang akong gisulat. I have limited space. So, this is actually the solution found in the book. Though, ang answer dyan is 159 grams. So, this one is being rounded off already. And I think they did not round off the molecular weight or the atomic weights of the elements into the nearest whole number. That is why they used here 294.2 grams. Nevertheless, this will be the same answer. Yung 158.76, if we round it off, we will still get 159 grams. So, para hindi kayo ma-confuse during quiz and exam, just read the instructions carefully and follow it, or follow the instruction kung ano yung nilagay ko doon, kung mag-round off ba or hindi. And kung mag-round off whole number ba or ilang decimal places. Okay? Wala na? Wala questions sa molarity? Are we going to move on now into the dilution of solutions? This one is still included in your laboratory sa activity number 6. So I hope you can still remember this. So we have dilution of solutions. When you say dilution, pinaulit-ulit ko ito sa laboratory, we are going to prepare a less concentrated solution from a more concentrated one. So, di ba yung example ko dito, kung nagtimpla kayo ng juice and you find it very sweet, it means very concentrated siya. Marami kayong masyadong solute or yung juice powder na na-dissolve. So, ang ginagawa natin, nagdi-dilute tayo. Nagdadagdag tayo ng water to make it less concentrated. So, sa laboratory, we also do that. If meron tayong very concentrated solution, pwede din natin siyang gawing less concentrated just by diluting. And when we do dilution, we only add the solvent. We don't add solute anymore. Solvent lang talaga ang ina-add natin. Okay? So, this one is just an example of the process. Prepare 1 liter of a 0.400 molar potassium permanganate solution from a solution of 1.00 molar potassium permanganate. So your hint there will be this word, from a solution. Galing sa solution na yan, which means, uy, ganun white naman ako. Wait lang. Galing sa solution na yan, and then, meaning, ito yung original solution natin or yung tinatawag nating more concentrated solution. You can see it's a number 1 molar. Ang gagawin is medyo mas maliit siya, that's 0.4 or 0.400 molar. Okay? So, yun yung problem. So for this purpose, we need 0.400 mole of potassium permanganate because there is 1 mole in potassium permanganate in 1 liter sa 1.00 molar natin. Pero actually, mas libog ni siya nung illustration. We will just go back to our C1V1 equals C2V2 later. Ginapakita lang din na pag naakay 1 molar na solution, it means naakay 1 mole sa 1 ka liter. Tapos, kung i-dilute ni mo na siya, so kung gusto na to 0.400 molar, it means magkakaroon na lang siya ng 0.4 din or 0.400 moles na, pero magbabago ang kanyang volume kasi lesser na dapat ito kasi nag-dilute tayo. So bigyan ko kayo ng more specific na example. Wait lang ha. Balikan ko yan later. I think I have it here. So we have describe how you would prepare 5.00 times 10 raised to the power of 2 ml of a 1.75 molar sulfuric acid solution starting with an 8.61 m stock solution of sulfuric acid. Dili sensitive ang sa dilution. Yeah, dili man siya sensitive. Either you use the ml or the liter, depende sa ginapangayo sa problem. Usahay ml, usahay liter, so you have to read the problem kung unsa nga unit ang kailangan. Pero for example, kung dili sila pareho og unit, ml or liter, pero you're looking for the molarity, then all you need to do is to convert one of them para magkapareha sila kay pag mag-divide na ta, dili naman ninyo to siya ma-cancel. So hatagan ta mo another example na kagaya niyan later. So dito muna tayo, describe how you would prepare this one. How you would prepare. So you're still going to prepare this one, which means na ito yung ating new solution. And by the new solution, this is actually the diluted solution. And then you have there starting with, which means ito class yung ating original solution or ito yung more concentrated one. Okay? So ito yung sample problem natin. Now, how do we compute that? In dilution process, we use this formula. MIVI equals MFVF, pero actually parehas lang na siya sa C1V1 equals C2V2. Itong C is for the concentration, the V is for the volume. Ito lang MI kasi since ang hinahanap is molarity instead of the C, instead of using just the concentration, this is more specific for the molarity. Kaya M ang ginamit. And then I lang ang ginamit na subscript, which means that's the initial or the original solution. And then the F will be the final. So I don't have problem whether in the solution you use this formula or you use this one. Kasi parehas lang din naman sila. Okay? So MI and MF, again, MI is the initial molarity. MF will be the final molarity after dilution. And that is also true with the volume. Now, the units for the volume must be the same. Either ml or liter, basta silang dalawa, the VI and the VF, parehas yung kanilang unit. So kung in the given, again, hindi magkapareho, you just have to convert one one of it para magkapareho na sila. Now, in doing the computation, you have to remember this. Always yan siya, class. Mas malaki si MI or yung tinatawag natin na C1 compared to the final molarity or yung tinatawag natin na C2. Okay? Siyempre, mas malaki siya kasi the process is dilution. We are preparing this one a less dilute or less concentrated na solution from the more concentrated solution. So kapag compute nyo, mas malaki yung C2 ninyo, you have to recheck your computation because you might have missed something in the process. Okay? So, pero pagdating naman kay volume, baliktad, class. The VF, the final volume, will always be larger than the initial volume. Or the V2 will always be greater than the V1. Bakit? Kasi when we do dilution, we add more solvent. Again, we add more solvent. Kung nakakaisa ka baso nga juice and you find it very sweet, di ba ang ginagawa, nag-a-add tayo ng water and this is our solvent. So pag-add natin ng water or ng solvent, syempre tataas yung volume natin. So this is how you check whether your computation is correct or not. Okay? So, before ko answeran yung example na yon, dito yan siya actually, galing pa rin yan siya sa molarity natin, class, na formula. Diba molarity is equal to moles over liter. Pero, ang ginagawa kasi natin, we just add here sa liters. We don't add sa moles. So pag nagdi-dilution process tayo, the moles of the original solution will still be the same sa moles ng new solution natin. So the difference now lies between the molarity and the liter. Kaya yung kanyang formula ang naiwan na lang, M1 or MI VI equals MFVF. So dalawa na lang sila naiwan, hindi na natin kino-consider si moles. Because again, hindi tayo nag-a-add ng solute kapag ka nagdi-dilution tayo. Ito yung nakasulat actually sa previous na slide. Solvent lang ang ina-add, hindi solute. So we don't compute for the number of moles anymore. So pwede na natin i-push yung ating computation nito. Let's let me just use the C1V1. Mas madali kasi siyang i-pronounce or mas madali siyang sabihin kaysa sa MIVI equals MFVF. Nalilito ako. So C1V1 equals C2V2. Mas hiyang ako gamitin itong formula na ito. So we will identify. Remember, I told you this is the original solution. So this will be the C1 here since this is concentration. And the volume is missing. So the volume is missing here. Now, how would you prepare? Meaning this one is the new solution, the diluted solution. So this one is in ml. So this is B2 and molarity here. So this is C2. All we need to do is to substitute these numbers sa ating formula. So we have C1, that's 8.61 molar, multiplied sa V1, which is not given in the problem, and this is missing. So yan yung hinahanap natin. And then C2 is 1.75 m. So as you can see, mas malaki talaga ang C1 from 8.61, naging 1.75 na lang siya. The V2 though is 5.00 times 10 raised to the power of 2 ml. Actually, that is just 500 ml. Tapos, i-multiply lang natin sila, class. So ito, hindi siya pwedeng ma-multiply. Siyempre. And then on the other side, 1.75 times 5.00 times 10 raised to the power of 2 is 875 molar times the ml. Okay? Next, let's isolate the V1. So let's divide both sides with the 8.61 m. And let's cancel the m here. So ang may iwan na unit ay in ml. So pag i-divide na natin 875 divided by 8.61, kung 2 decimal places, then the answer here is 101.63 ml. This will be the final answer. Pero ang tanong niya kasi, how would you prepare? Meaning yan, kukuha ka class ng 101.63 ml of the original solution, which is 8.61 molar. Tapos dagdagan mo siya ng solvent until the volume becomes, ilan yun? 5.00 times 10 raised to the power of 2 ml. So kapag ka naging ganito na ang kanyang volume, automatic, ang kanyang molarity will become 1.75 molar. So that's how you will prepare the solution in the laboratory. Questions so far about dilution? Any question? Kung i-check mo yan, class, yes, mas malaki ang C1 kaysa kay C2. And yes, mas malaki yung V2 kaysa kay V1. The V1 is just 101.63 while the V2 is 5.00 times 10 raised to the power of 2. That is actually 500 ml. So I hope by now you have mastered how to compute the molarity and how to compute dilution problem. Sa book, ito yung final answer nila. This is just rounded off to whole number. That is why 102 ml. Okay? Naulit lang ito, class. Sabi ko kanina, sa dilution process, we only add solvent. We don't add any more solute. Thus, the moles of the solute do not change during the dilution process. Okay? Questions? Let me add a blank slide here. And let me give you a problem na pwede niyong pagpraktisan. Wait lang. Okay, so you try and kindly send your answer sa chat box for your participation sa class this morning. What is the molarity of 250 ml solution prepared from, okay, take note of the word prepared from 100 ml of 0.56 molar hydrochloric acid solution. Please understand the problem, try to compute it, and send your answers sa chat. Let's wait for the others. Okay, let us see. Wala na yung magpahabol. Let me just refer this kasi makalimot ko. Ay, nagsulfo din sa amo. Wait lang ang madunggan ninyo. 1K. Garcia. Regardless kung tama or mali ni ha, Garcia. Okay. So let's have the computation. We'll have what is the molarity of 250 ml solution prepared from 100 ml of 0.56 molar HCl solution prepared from, meaning this one is the C1 and this is the V1. Definitely, this will be the V2 and that the second concentration is missing. So it's the same thing, C1 V1 equals C2 V2. The C1 again is 0.56 m. Multiply natin sa volume niya, 100 ml. And then, we are looking for the new concentration in molarity. Pero yung volume niya from 100 ml, nadagdagan ng solvent, naging 250 ml na. So, 0.56 times 100 is 56 molar times ml. And then on the other side, we have the C2 and 250 ml. Let's divide both sides with 250 ml para ma-isolate natin itong C2 in this side. Let's cancel ml. You will be left with molar. So 56 divided by 250 is 0. You can answer 0.22 or 0.224 molar. So this is now the computation. If you want to check kung tama ba siya, the C1 is 0.56. Dapat mas malaki yung C1 kaysa kay C2 and the C2 is 0.224. So yes, mas maliit siya and this one is a reasonable na answer. So let me check again your submissions here. 0.224 or 0.22 molar. Okay, so yeah, you got the correct answer. Bakit may 2M? 0.22. And bakit may 0.23? You cannot round this off sa 0.23 because this is 4. So, di ba, pag hindi yan siya pumatong sa 5, hindi tayo mag-a-add ng 1. Okay. So, 0.224. Okay. 0.5. Ano? 0.56 na yun, ano? 0.56. Saan daw? 0.56. Nakalimutan ako ang 0 plus. Wait lang. 0.56 no ang nilagay ko. Wait lang. 0.56 molar Tapos, 56 na lang nilagay ko. Yeah, tama siya. 0.56 times 100. Tinimes ko pala ito. Kaya hindi na siya 0.56. Dito lang siya 0.56 plus. 0.56 times 100 equals 56. Kaya naging 56 na siya dito. And then, i-divide mo siya sa 250. Kaya siya naging 0.224. Any question for this? For this one, it's 11:56. Wala. How about sa molarity? Basig na amoy na ibugan dito sa molarity. You can raise your questions now. Because tomorrow we will continue with the gravimetric analysis and acid-base titrations, and you will be expecting more computations for this. Especially for gravimetric analysis, we will be having the balancing of the equation, and at the same time, we have a lot of steps in the computation for gravimetric analysis. Both of them, the gravimetric analysis and acid-base titrations, are strategies that we use to compute for the amount of substance or the concentration of a solution which is unknown in the laboratory. Because there will be times na ganun. Meron tayong mga chemicals na hindi natin alam kung ano yung composition niya or ano yung chemical formula niya. Hindi natin alam kung ano yun. So, i-identify natin sila using gravimetric analysis, or meron ding mga times na hindi natin alam yung concentration. Alam natin yung chemical formula. Example, we know that this chemical is hydrochloric acid, but we don't know the concentration. So through acid-base titration class, we can actually compute and know the concentration of that chemical substance. So yun yung pag-uusapan natin tomorrow. I hope you will not be absent tomorrow kaya medyo taas-taas na siya nga computation, and it's a bit more complicated compared sa mga previous nato na computation. So, any questions so far? Katong may mga corrections sa quiz, nag-submit na ba mo message ninyo dito sa Schoology? Kaya ako na siyang i-check later. Kaya i-recheck na ko yung submission one by one.